Welcome to this Unit 2 and Chapter 3 practice test as we prepare for our unit test. So let's take a look at these questions that you have in your handout and let's solve them. Number 1, identify the intersection of plane ABD. So I'm going to go ahead and highlight that. So A to B, and then you'll notice I went to C. That's because we're talking about the bottom here. So here's that plane on the bottom. So that's the base of that pyramid. And plane CDE. So let's go ahead and use a different color. So CDE is over here. Now you'll notice where these end up touching each other are right along here. Now, let's go ahead. I'm going to erase that which I colored in the blue and in the yellow, and so then we can see what exactly that kind of shape is. Now remember that two planes always intersect on a line. So we need to write a line. Now you'll notice that I have the C and the D. Now technically these could continue on forever here. So we're going to write that the answer here is line CD, or you could write line DC. Either way is fine. Here it says name a segment skew to BC. Okay, so skew, remember, means never touches, and it goes in different directions. So it tells us segment BC. So let's go ahead and highlight that right here. So now, if you notice, for instance, CD intersects BC, so that's not going to work. EC also does the same thing, it touches. So does AB. But notice here we have EA. That's another one we want to consider. In EA, the question would be, will it ever touch, or does it go in different direction? And the answer is it will never touch, and it does go in a different direction. So this is the line we're after. The other line to consider would be this one here, AD. But AD won't touch it, but it is parallel to BC. So we're going to use this line EA. Or you could say AE. Now, I'm going to go back and look at the answer, or the question rather, and notice it said segment. So that means that I need to change my answer just slightly and write these as a segment. So I'll just put a little bar above those names. So let's go ahead and identify the angles that they say here in terms of their named relationships. So we have 5 and 13. So here is the 13, and here's the 5. You'll notice here we have lines A and B are parallel. If you look at this intersection, angle 5 is on the top right, and over here in this intersection, 13 is in the top right. That makes these angles corresponding. Next we have angles 7 and 12. Let's go ahead and mark where those are at. So here's 7 and here's the 12. Now again, A and B are parallel. So you'll notice that 7 and 12 are alternate. And then because they're on the inside of the two parallel lines, we'll say interior. Next we have 9 and 16. So here's our angle 9, and here's our 16. Now, D and E are not parallel. However, angles 9 and 16 still would have the same named relationship whether they are parallel or not. Now, these would not be equal anymore because they're not parallel, but they are alternate exterior. So here it says given A is parallel to B, let's go ahead and mark that as parallel, The measure of angle 6 is 89 degrees. So I'm going to go ahead and write that in. So right here is 89. Find the measure of angle 10. Now notice that angle 10 and angle 6 are going to be same side interior, or we call them consecutive interior. So I'll write that down here just to remind us. So same side or consecutive interior angles. And those are always supplementary. So I know that the measure of angle 6 is 89. So I'll have 89 plus the measure of angle 10 equals 180. So I can subtract 89 from 180. So we have 180 minus 89. And that's going to give us 91 degrees. So that's equal to the measure of angle 10. Here it says find the values of x and y given that A is parallel to B. This time it says the measure of angle 8, so I'm going to go ahead and erase this 89 because I've got some new information. So measure of angle 8 is 4x plus 10. The measure of angle 12 is 7x minus 17. And the measure of angle 11 is 3y. Okay, so let's take a look at the 8 and the 12. You'll notice 8 and 12 are also consecutive interior. So that means we're going to have that 4x plus 10 plus 7x minus 17 is going to be equal to 180. Now, if you need to work on a separate sheet of paper to give yourself some more room, feel free to do so. Now the 4x and the 7x, that's going to give me 11x. And then we have the 10 and the negative 17, which will give me negative 7. And that's equal to 180. And we'll go ahead and add the 7. So we'll have 11x equals 187. And we'll divide the 187 by 11. And x will equal 17. So we'll write that over here. So x equals 17. And now we need to find the y. So here we have the measure of angle 11. Now the 8 and the 11 are equal to each other. So what I'm going to do here then is set them equal to each other. So I'll have 4x plus 10 equals 3y. But remember the x equals 17. So I'm going to go ahead and erase this x. And I'm going to write 17 in here. So 4 times 17, so that's going to be equal to 68. And we have plus 10 equals 3y. So I have 78 equals 3y. So when we divide 3 into 78, we get y equals 26. Here it says determine the slope of the line that contains the given points. So we're going to go ahead and use our slope formula, which is m equals y2 minus y1 over x2 minus x1. I'm going to label these points. So here's my x1, here's my x2 with the 5, 11 is y1, and 7 is y2. Let's go ahead and plug in these numbers. So m equals, and we'll have 7 minus 11 over 5 minus negative 5. Well, this is going to give us 7 minus 11, which is negative 4. 5 minus a negative 5 is really a plus 5. So we'll end up getting 10 over here. Then we'll simplify this to negative 2 over 5. So I'll write m equals negative 2 fifths. Let's do the same thing for the second problem. label the points, x1 and y1, x2 and y2, of 0 minus negative 1 over 14 minus 7. Again, notice the two negatives, so we'll change that to a plus. And we'll have 1 over 7. Now here it says a slope of a line parallel to y equals x. Now remember that y equals mx plus b is slope-intercept form. So if I added some numbers in here to the y equals x, this would be y equals 1x plus 0, because 1 is the coefficient of x. You don't need it because it's the number that's going to keep that exactly the same. It's called the multiplicative identity. Then here we have plus 0 because you'll notice there's no number over here. So if I add 0, that tells us the y-intercept is 0. Now the slope of this line is equal to 1. So if we talk about a line that's parallel, that means to have the exact same slope. So the new slope will also be equal to 1. So here we need to determine whether the two lines are either parallel, perpendicular, or neither. So let's take a look at this. Like we did before, let's label the points. So we'll go with the 1 as an x1, and then the negative 4 is the y1, x2, y2. Let's find the slope of BT. So I'm going to write that like this. Slope of line BT. And we'll have 12 minus negative 4 over 5 minus 1. So here we have this minus a negative again, so we'll change those to plus, and that's going to give us 16 over 4, which equals 4. So I'm going to write that over here. So this line BT has a slope of 4. Now, let's take a look at this next one. x1, y1, x2, and y2. So now we have the slope of MV. So we'll do 2 minus 3 and negative 4 minus negative 8. There's our minus a negative once again. So we end up with negative 1 over positive 4. So the slope of MV is negative 1 over 4. Now notice that these two numbers are opposites of each other and they're reciprocals of each other. So that tells us that we have a relationship that is perpendicular. And you can go ahead and you could use the symbol instead if you'd like. Remember that the symbol for perpendicular is an upside down T. The symbol for parallel, it looks like two L's next to each other, so we can use either one of those. All right, let's take a look at number 12. Now I'm going to go ahead and bring number 12 down here. So here's my x1 and y1, x2 and y2. So we have the slope of BT again. We'll have 17 minus negative 7 and 10 minus negative 5. Change those to additions because they're subtracting the negative, and we have 24 over 15. Now this can simplify because 3 goes into 15 5 times and goes into 24 8 times. So in this case, we have a BT which has a slope which is 8 over 5. So let's go ahead and find the slope of the second one, MV. So x1, y1, x2, y2. And I'll write that like this. And we have 6 minus negative 10 over 5 minus negative 5. A lot of negatives in these problems. So change those to pluses. Oops. There we go. So this time we get 16 over 10. Notice if we were to simplify this, 2 goes into 10 5 times and goes into 16 8 times. So we have the slope of mv this time is going to be 8/5. Well, notice those are exactly the same. So here we're going to have an answer which is parallel, which again you can also use the symbol, which is like two L's next to each other. Okay, so the first answer perpendicular, second answer parallel. Let's take a look at this last one. Wonder what we'll get here. So x1 and y1, x2 and y2. Let's come down here for number 13. So we're going to have the slope. Let me go ahead and label that with the name first. BT is my first line. So we have -1 minus -5 over 5 minus 3. This is going to give me -6. No, it's not. I didn't change that to a positive. It's going to give me +4 over 2, which is 2. Okay, so BT in this case is 2. So now we have the second line, x1, y1, and x2, y2. So the slope of MV is going to be 3 minus 6. And then we have 4 minus -2. Change that to a plus there on the bottom. So we get -3 over 6, and that is -1/2. The slope of MV is -1 over 2. Now notice once again, just like in the case of number 11, we have a situation where we have opposite reciprocals. So we do have a perpendicular relationship. So here let's write some equations. So we need to write them in slope-intercept form. Now remember there are two forms. We have slope-intercept form. I'll call it SI, which is y equals mx plus b. And then we have point slope form. I'll call it PS, which is y minus y1 equals m times x minus x1. Now we're going to use the point slope to get to slope-intercept. Here it says we have a slope of 7 and a y-intercept of -8. Well, if they already gave us the information we need, the m and the b, we can just write the equation. Y equals 7x minus 8. Here is an example where we have an x1 and a y1, so we do want to use point slope form. So I'll have y minus 8 equals -4, and we'll have x minus -4. And these are going to turn into pluses here. Then I'll go ahead and distribute the -4 to the inside. So I have y minus 8 equals -4x minus 16. And then I'll add 8 to the -16. So I end up with y equals -4x. We add the 8's, and we get -8. Here we have an x-intercept of -5 and a y-intercept of 2. Okay, so what that means is an x-intercept is a point which is -5, 0. So that's the x-intercept. Then we have the y-intercept, which is at 2, so that's 0, 2. So what we can do here, I'll go ahead and work over here. So we'll have y minus, and I can go ahead, let's just use this point here, 2 equals, now we need the slope. So let's find the slope. So we'll do 2 minus 0, which is 2. 0 minus -5 is +5. So I'll have 2/5 over here. And then I have x. And then I've got -0. Well, I don't really need to include that, so I can just put x. So if I add 2 to both sides, You'll notice my equation is y equals 2/5 x plus 2, and we're done. Here we have a word problem, so let's take a look. Tanya joined Alphaville Motors as a car salesperson in 1998. The number of cars she sold increased at an average rate of 25 cars per year. Okay, so the 25 cars per year is going to then be the slope. So let's keep that in mind. Very important. It says in 2001, she sold a total of 237 cars. If the number of cars Tanya sells continues to increase at the same rate, how many cars will she sell in 2007? So here we have, in 2001, our first year that's mentioned is 237. So then each year it's going to increase by 25 cars. So if we go ahead and take this and add 25 in 2002, you're going to have a total of 262. And let's go to 2003. And we get 287. And 2004. And here we get 312. And then 2005, we're almost there. 337. And then 2006, we'll end up with 362. And then finally in 2007, we end up with 387 cars. Okay. Let's take a look here. It says, given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So this is sort of a segue into proofs. So it says angle QSR, so let's find that, QSR, so this is this angle 2, and SUT, so SUT, okay, so SUT is down here, so these two are congruent. So now if we said those are congruent, that would make this line RS parallel to this line TU. And how do we know that? Those are corresponding angles. So we can just write that, corresponding angles. Angles 1 and 2, so let's go ahead and mark those. So here's the angle 2, here's angle 1. Notice those are going to make these two lines, the vertical lines, parallel. So we'll say that line RT is parallel to line SU. And the reason there is alternate interior angles. All right, let's look at this next one. Now it says that we have the measure of RTU, so RTU, so that'd be right here, this one here, and TUS, so TUS, so these two angles are supplementary. So again, that would make the RT and the SU parallel. And those there are consecutive interior. I'll abbreviate that and I'll put angles. Okay, brand new set of problem, or no new problem here. Find the value of x so that P is parallel to Q. Okay, so here we have this angle 12x minus 11. That's right here in this corner. And then we have this 4x minus 1 here in this corner. Now, if P is parallel to Q, which is what we want to say that they are, these two would be the consecutive interior. Remember, another way to say that is same side interior. And those are always supplementary when we're in a parallel situation with a transversal. So we'll have 12x minus 11 plus 4x minus 1 equals 180. So let's go ahead and solve this equation. So I'm going to go ahead and move that over here, give myself a little bit more room. Okay, so now I'm going to go ahead and add these together. So we're going to have 16x minus 12 equals 180. We will subtract that 12. So we'll have 16x, or rather, we'll add the 12 to both sides because it's negative. And then we get 192. And then we'll take 192 and divide that by 16. And we get x equals 12. So if x is equal to 12, that is going to make these two lines parallel. Okay, here it says find the distance between each pair of parallel lines. Okay, so let's go ahead and graph these. That's going to be probably a good way to do this. So 3x minus 1 and 3x minus 11. So the 3x minus 1, we'll put that right here. Here's the minus 1. Up 1, 2, 3 over 1. Do that maybe a couple more times. And I'll go ahead and connect those points. I'll move that over just a little bit. I'm going to come down here and do a couple extra points. So go down 1, 2, 3, left 1. Just to make sure I've got plenty of points here. And then I've got this 3x minus 11. So I'm going to go ahead and write y equals 3x minus 1 on this line. And then the 3x minus 11, now it's going to come down here a little bit below that graph, but that's okay. We can put that little point right there. There's a point. So we get several of those points. And then we can draw the line through those points, like so. So this is the y equals 3x minus 11. Now really, all we need to do is be able to get a line that's perpendicular and find the length of that. Anywhere along here. Doesn't matter which line we choose. So what I'm going to do is I'm going to count up and over. So you notice that's up 1 and it's to the left 3. So when I find the distance here, I'm going to do my Pythagorean theorem because I want to find this length right here. So I'll have 1 squared plus 3 squared equals, and I'll just use x squared. Here I'm going to get 1, because 1 times 1 is 1, not 2, plus 9 equals x squared. And then I have 10 equals x squared, and we'll square root that. So x is equal to the square root of 10. And so that is your final answer. Let's go ahead and go back and put that in. So number 23, square root of 10. So here we have negative 5x and negative 5x plus 26. Okay, so let's go ahead and go to our graph. Now I'm going to have to go by something more than a 1 because I'm not going to fit the 26 on the graph. So we could go up by 5s. That would be a good idea. We could go up by something different if you'd like, but I'm going to go up by 5. So this would be 5, and each block would be 5. So the 5x is going to have a y-intercept of 0, and you're going to go up 5 over 1, like so. Now I know that that's up 25 over 5. That's the same as going up 5 over 1 and putting a dot. And up 5 over 1, 1, like so. And it ends up connecting. So I can go down 1, 2, 3, 4, 5 over 1. That's going to give me a really good picture there of that graph. Okay, so I'll just move that over just slightly. I don't love how I drew that, so I'm going to go ahead and change this up just a little bit. There we go. So this is the y equals 5x. And then I'm going to go ahead and plot the plus 26. So we'll go up 5, 10, 15, 20, 25, and then 26. And then I'll go up 1, 2, 3, 4, 5 over 1. So I'm a little bit above here, so I'll go down 2, 3, 4, 5, and over 1, and that's going to give me a really nice looking picture there. Okay. Now a problem like this is not as easy to count. So what I'm going to do is I'm going to focus in on 2 points that I know pretty easily. I'm going to find the distance between those. So I've got this coordinate here, which is 0, 26. And I have this other point, which is 5 and then 25. Let's use these numbers and use the distance formula. So I've got my x1 and my y1, my x2 and my y2. So let's go ahead and let's subtract the x's. So we'll have 5 minus 0 squared, and then 25 minus 26 squared. So that's going to give me square root of 5 squared plus negative 1 squared. Now 5 squared is 25, negative 1 squared is 1, so I end up with the square root of 26. So that's going to be my distance. So here it says create a line perpendicular to L, so here's L, through the point 2, 3. Let's go ahead and get that point. Now, what we want to do is determine the slope of line L. So the slope of line L, and I'm going to go ahead and start with a point that maybe I can see. So here's a good point, and here's another good point right next to each other. That's going to be a slope of negative 1. Now the slope of a line that is perpendicular of this new line will be equal to 1. So I'll say new slope. The reason I know that is because the opposite reciprocal of negative 1 is 1. So we'll go ahead and we will get some points. So from here we'll go here. We could go above if we'd like and keep going. Okay, now this is the point that we're going to use to find the distance. But let me go ahead and construct this line by drawing a line there. So I have these 2 points that I need to find the distance between. So this is this point Q, and this is the point we're going to use for that line L. So that point there is negative, I do have a lot of stuff here, but negative 2, negative 1. And we know that line, or point Q is 2L, 2, 3, excuse me. So we're going to find the distance by labeling these x1, y1, x2, y2. And we'll go ahead and subtract the x's, so 2 minus negative 2 squared. And then we'll have 3 minus negative 1 squared. We'll go ahead and work over here. So we'll end up here with a 4 because you've got the pluses. So 4 squared Over here we'll also have 4 squared, and you end up with 16 plus 16, which is equal to the square root of 32. Now, the square root of 32 will simplify, so we can break this down into the square root of 16 times the square root of 2. And the square root of 2 is, of 16, excuse me, is 4, so 4 square root of 2 is our distance. Finally here, number 26. Draw and label a figure you could use to prove the theorem. If two lines in a plane are cut by a transversal, well, let's go ahead and draw that first. So here we go. So two lines cut by a transversal. So that the pair of alternate interior angles is congruent. Okay, so let's go ahead and mark these congruent. We could have marked those, it doesn't matter. Then the lines are parallel. Okay. So it says state the given and the statement to be proved. So our given in fact, let me go ahead and write the statement first, then I'll say that's the given. So the given is that the alternate interior angles are congruent. The thing that we want to prove is we want to prove that these two lines are parallel. The way that we would do that is by the converse of alternate, I'll abbreviate this, interior angles. Okay, so here we have a couple proofs that we'll work through. And remember, this is an introduction to proofs. So if you're struggling to write these on your own, you're definitely in the majority. These are very challenging. So it says that A is parallel to B. So that's going to be our given information. So I'll write my reason as given. We want to prove that the measure of angle 4 plus the measure of angle 7 is equal to 180 degrees. So this is what we're trying to prove, so I put that at the end. Now, what I want to do is I want to find a way to connect the 4 and the 7. Okay, so notice 4 is on the exterior and so is 7. So what I'm going to start with is I'm going to say that 4 and 2 are supplementary. So the measure of angle 4 plus the measure of angle 2 is equal to 180 degrees, and that is because they are a linear pair. Then I'll say the measure of angle 2 is equal to the measure of angle 7. You'll notice those are corresponding. Corresponding angles. Then I can take the 7 and substitute it. So by substitution, I then know, I'll write property, the measure of angle 4 plus the measure of angle 7 equals 180. Let's take a look at this one. It says that A is parallel to B. That's our given. We always put the given first. We want to prove that angle 2 is congruent to angle 6. So I put that at the end. Now I don't know my reason yet. We'll find that out. So earlier it was substitution. We'll find out here what this one is. So 2 and 6. Now we know those are alternate interior, yes, but let's prove that alternate interior angles are congruent using another set of angles. So let's connect those. So here's what we could do. We could go with the 2 and the 7 like we did before. So I could say the measure of angle 2 is equal to the measure of angle 7, and we mentioned those were corresponding. Angles. And then you'll notice the 7 and the 6, so the measure of angle 7 is equal to the measure of angle 6, and these are vertical angles. So then if 7 is equal to 6 and 7 is equal to 2, Well, then 2 would be equal to 6, of course. So I'll say the measure of angle 2 is equal to the measure of angle 7, or rather 6. And this would be by substitution. Now, I also mentioned in the notes that we could also say here, if we wanted, instead, transitive property. So it's either substitution property or transitive property. Either way will work there. Then you notice how I went from equals to congruence? So then what I say here at the very end is the definition of congruence. Now, I could have started with all of these as congruent and avoided this last reason, and instead substitution or transitive property would have been at the end. But I decided to go with the same kind of statements we were making in the first problem. So finally here we have a more difficult proof because it's a little more abstract. It says given line AD and GE are crossed by HC, and the angle GFB is congruent to DBF, so those are marked. Prove that AD is parallel to GE. So it says don't use converse of alternate interior angles because that's what we're actually trying to prove. So in other words, what we need to do is write our given. So we're going to say here that line AD and GE are crossed by line HC. And we're also going to say that angle GFB is congruent to angle DBF. So this is our given information. Now we're trying to prove, which I'll put down here at the end, that AD, line AD, is parallel to line GE. Figure out our reason in a moment. Very much like the problems up above, let's go ahead and use some sort of a connection between this angle here, the DBF and the GFB, such as vertical angles could work or corresponding. So I'm going to go with vertical angles first. So what I'm going to say is that angle DBF is congruent to angle ABC. And these are vertical angles. Then I'll say that angle ABC is congruent to angle GFB. So I've got these three angles equal to each other. And those are corresponding angles. And then if those are equal, notice that ABC is in both, that means DBF and GFB are going to be equal as a result. So I'll go ahead and change colors here. So we'll say that angle GFB what I realize is we don't need to worry about that angle there. We've already established the connection. So what we can say here is because we ended with corresponding angles, we can say this is the converse of corresponding angles. That will prove, because these are equal, that those lines are parallel. All right, I hope this helps you prepare for the test. Have a wonderful day.